So we start with a new topic, that is the basics of artificial neural network. So a neural network consists of many neurons, which is actually given like x1, x2, x3, and it is connected with weight. Some weights is given like w1, w2, w3, and h is a function, right, which is actually taking the summation of xi dot wi, where I is the number of components or the neurons, right, irrespective of the number of weights given. Okay, now this is a h is actually then again first to activation function, which we call it as f, and finally from f we actually compute the y function. So what is h? H is nothing but the summation of xi wi, right, which is x1 w1, x2 w2, x3 w3, which also have seen from this figure. So finally from h, as I mentioned, right, this h needs to be passed through this activation function to compute the output y or y cap. Okay, now what is this y function? So this f of h is actually rewritten as f of x1 w1 plus x2 w2 plus x3 w3, which is nothing but 1 divided by e to the power minus x1 w1 plus x2 w2 plus x3 w3. Now you will be wondering, right, where this activation formula, the function is coming from. So if you remember, it is coming from the logistic regression. Okay, now let's come to the logistic regression concepts. So given an input x, we want a x cap where probability of y is equal to 1 given x, where x belongs to the space R of nx and w belongs to R of nx, and b, right, b is some bias, right, we can consider, which is also a kind of a real space, providing the output y cap from this neural network. Okay, so using logistic regression we can provide this output, or denoted this output y cap is equal to sigma of w transpose x plus ys, which is also represented by sigma of h. So this is nothing but the sigmoid function in the logistic regression. So how the function behaves or looks? So as sigma of this h is given by 1 plus e to the power minus h, so it is in between like 0.5, right, where it provides a sigmoid function, correct? Now let's take an example to understand the idea. So let's say I have a neuron x1 and x2, which value is 0.8 and 1, connected with weight vectors, I can say, or weighted value w11, w12, w13 for x1, and x2 w21, w22, w23. Okay, so we already provided the inputs 0.8 and 1, and w is represented as this 2 cross 3 matrix. Okay, and we also provide the value of w as 0.2, 0.7, 1, 2, 0.6, 1.8. Now we do a multiplication. Sorry, I just take a color. So this is your x and this is your w value. So it's a kind of a matrix multiplication. So 2 plus 2 is in a matrix, cancel out. So final dimension will be 1 cross 3. So if you see here, so this is actually 1 cross 3 matrix as I mentioned here. So this is 1 cross 3 matrix it will come. So if I multiply, right, 0.8 to put this column, so 0.8 cross 1.2 plus 1 cross 2. Okay. Now 1.81, so this is 1.87, so this will multiply, and 1 cross 0.6. Similarly for this 0.8 for the third column, 1, and for 1 into 1.8. So final, what is the value of h? It will be x into w, which is actually nothing but 2.96, 1.56, 1.8. Now we pass to this activation function, which is 1 divided by 1 plus e to the h. So we already have a value for h. So finally I got a value of a as 0.95, 0.83, 0.86. We call these values as a1, a2, a3. And we also have a w dash value, which values are given 1, 0.9, 1.5. So what is this w, and where we are with this activation value? So let's come to the figure here. So these are the value of w1 dash, w2 dash, w3 dash, correct? From there we need to again further compute the activation function out of this h dash matrix. H we already computed, which is nothing but your x into w. From here we pass to the activation a1, which we also computed. So 0.95, 0.83, 0.86. These values are coming from this, right? Clear? I think this part is very clear, right? So these are the values we are getting a. So this is the a value which I actually put it here. Hope that is fine. Now we have to find for w. So these values are also w dash, w2 dash, w3 dash. These values are also given. Okay. Now what we will do? So what we have to do? We have to actually do kind of a multiplications here. So let's come to that, the next slide. So this h dash, so if you see that figure, we already have this h dash where we have to multiply this activation function into w value, this value. So this is what the inner value is, 1 cross 3, 3 cross 1. So this got cancelled. So final dimension is what? 1 cross 1. So h dash is your 2.9. So if I pass to the sigmoid function, which is nothing but 1 divided by 1 plus e to the my h dash. So this value I put here. So final output is giving 0.95. Hope the idea is clear to everyone. So let's come back to the previous slide. So this is how we'll get the output. Okay, computing this a1 dash, h dash, a1, h, the values coming from x1 and x2 as an input with the different bit vectors. Okay, so this is all about the basic concepts of the artificial neural network. So please provide a like of this video. So thank you very much. Okay, bye bye.